Uh, in my previous lecture, we have discussed the finite automata uh, have only have only binary outputs. That is, either they accept the string or they do not accept the string. This acceptability was decided on the basis of reachability of the final state by the initial state. Now we remove this restriction and consider the model where the outputs can be chosen from some other alphabets. Here we have two types of machines. These machines are called finite automata with outputs. One machine is Mealy machine. Mealy machine. In Mealy machine, the value of the output zt, is a function of present state qt and present input xt. Correct? Where lambda is called output function. The generalized model of this pattern is called Mealy machine. Second machine is Murray machine. Murray machine, in which output zt is a function of qt only, state only. Such machine is called Murray machine. This is the most restricted model. This machine is also known as input independent machine. Input independent machine, because in Murray machine output is only depend on the state only. Correct? Means machines का आउटपुट मशीन के इनपुट पे डिपेंड नहीं करता है. मशीन में आप कुछ भी इनपुट दीजिए, मशीन का एक फिक्स्ड आउटपुट ही आएगा. ये मशीन आपकी होती है Murray मशीन. In more detail, the exact definition of Murray machine is a Murray machine is six tuple. It is six tuple q sigma del lambda and q0, where q is finite set of state, sigma is the input alphabet, sigma is input alphabet, del is the output alphabet, again del, this is also known as del, is a transition function, which maps sigma into q, and lambda is also known as output function. Which maps q into del. State will map only output, and q0 will be the initial state. This six tuple constitutes Murray machine. It is six tuple q, sigma, del, lambda and q0. Next definition is Mealy machine. Mealy machine, it is also 6 tuple. It is also 6 tuple. Same tuples are same q, sigma, del, lambda and q0. Description is same as it is: set of states, set of inputs, output function, transition function, output alphabet, transition function, output function and initial state. There is a difference in output function only. The output function will map sigma into q into del. In Mealy machine, the output function lambda will map sigma into q into del. This is the main difference between Mealy and Mealy machine. And Mealy machine will map q into del, करेक्ट. इसका डेल और इसके डेल में थोड़ा सा डिफरेंस है. सिग्मा इंटू क्यू विल मैप डेल एंड state will map del only, because Mealy machine is input independent machine. so इसलिए इसमें इनपुट नहीं होगा. स्टेट केवल आउटपुट पे जाएगी, आउटपुट डिसाइड करेगी. इस पे स्टेट एंड इनपुट both will decide the machine's output. So the Mealy machine is input independent machine and this is input dependent, in which present state and input will decide the output of the machine. In tabular representation, Mealy machine will like this: present state, machine's next state, input 0 and 1. Let for example, this Mealy machine will have initial state q0. For input 0 it will go q3 state. For input 1 it will go q1 state, and machine's output lambda is 0. At state q1, machine's next state is q1, and for input 0 and for input 1 its next state is q2. Output is 1. For state q2, the machine's next state is q2 for input 0 and q3 for input 1, and output is 0. And for state q3, the machine's next state is q3 for input 0 and 0 for input 1, and machine's output is 0. So the Mealy machine in tabular representation will look like this: present state, machine's next state. Present states are q0, q1, q2 and q3. For these states, their different transitions are given in table for input 0 and for input 1. But in case of Mealy machine, For every state there is only one output. For state Q0 machine's output is 0. For state 1 machine's output is 1. For state Q2 machine's output is 0. For state Q3 machine's output is 0. For using this table, if we generate the transition for some string, let for a string equal 0 1 1, the transition state, as you know, from starting state Q0, for starting state Q0 and input 0, it will go on state Q3 and machine's output will be 0. And from Q3 for input 1, for state Q3 for input 1, it will go state Q0 and output 0. And for from state Q0 for input 1, from state Q0 for next third input, that is 1, it will go on Q1, the output will be 0. And from Q1 for input, again for last input Q2 1, it will go on Q2 and output 1. And again at last input is AND, and after input there is no string, that means there is null string. And for null string at state Q2, machine's last state is Q2, from state Q2 for null string it will again show the output 0. It will again show the output of 0. That means it is input independent machines, and machine will show for null string also the machine's output will be 0, because at state Q2 is the last state and Q2's output is 0. So machine will show the output 0. That means for the string of length n, machine's output is n plus 1 in case of Mealy machine. That means input of length n, the machine's output will be n plus 1. And for input in case of Mealy machine, and in case of Mealy machine of input length n, the machine's output will be n. You can test the same input for some Mealy machine also, and I will give one more example of Mealy machines and its representation of Mealy machine in tabular form. But in case of Mealy machine, the input of length n, the output will be n plus 1. Correct? Next example of Mealy machine. And Mealy machines tabular representation. Mealy machine's tabular representation will be like this: present state, next state, and next state will divide it input 0 and 1 into next state and output, next state and output. For from initial state Q1, its next state is Q3 and output is 1, output is 0. And for input 1, its next state is Q2 and output is 0. State Q2, next state is Q1, output is 1. Next state is Q1 and next state is Q4 and output is 0. From state Q3, its next state is Q2 and output is 0. Next state is Q1 and output is 1. And from state Q4, its next state is Q4 and output is 1. For input 1, next state is Q3 and output is 0. Correct. For some string of the length 0011 of length n equals 4. Here is the string 0011 is of length n equal 4. Now you can check this string from initial state, that is from Q1 for input 0. From Q1 for input 0 it will go next state Q3 and output is 0. From Q3 for input 0, from input 0 will go on Q2 and output is 1. From Q2 for third input 1, from Q2 input 1 it will go Q4 and output 0. And from Q4 for last input 1 it will go Q3 and output will be 0. So here the machine will stop. The final output is Q0 and output length is n 0100, that is length of output is 4 and length of input is 4. In case of Mealy machines, for the input of length 4 the output will be of length 4, and in case of Mealy machine, as you have seen, in case of Mealy machine of input length n, the output will be of length n plus 1. Correct. These are the explanation of Mealy and Mealy machines. Now you can convert the Mealy machine into Mealy machine, and from Mealy machine you can obtain equivalent Mealy machine. This conversion will be discussed in next class.